Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. My name is Sanaullah. My CMS ID is 031170012, and I'm here to present you the Vlsi presentation. My topic is defect in crystals, assigned by Dr. Saeed Ahmed Khan. Now, first of all, introduction. So, crystalline metal has a crystal structure in which the atoms are positioned in perfect order pattern which is repetitive over large atomic distance. Defects have a profound impact on the macroscopic properties of materials. Sometimes defects are deliberately created to improve properties of crystals. Crystal defect imperfection in the regular geometrical arrangement of the atoms in a crystalline solid. These imperfections result from deformation of the solid, rapid cooling from high temperature or high energy radiation. Actually, imperfection is caused due to the solid, due to the deformation of the solid, due to the rapid cooling from high temperature, or it may be caused due to high energy like X-rays or neutrons. So these are the cause of the imperfection of the crystal, or you may say the defect in the crystals. Now, first of all, imperfection in crystals. There are two types. The first one is the electronics. Electronics are further divided into two types. The first one is due to temperature or heat. Electron disturb. This imperfection is due to movements of electron, and it is also called thermal imperfections. So basically this imperfection is caused due to the movements of electrons. If we see in the figure, there are conduction band and valence band. Let's suppose in valence band there is NaCl, and conduction band there is the ion of NaNCl, and between the valence and conduction band there will be formatted or forbidden energy gap. Now the second one is it can be formed due to the holes or electron. They form semiconductor or electrical properties like n-type and p-types. So these imperfections can be caused due to the holes or electrons. Like if we see in the figure, it is lithium battery connected with a source. When we apply the source, then one side is anode, the other side is cathode. So there can be holes or electrons. So it can cause imperfection in the crystals. Now, classification of defect in crystals. So actually there are four that is classified into four types. The first one is the 0D point defects, the second one is the 1D line defects, then 2D surface or interference, 3D volume defects, and 0D. There are the four types. Actually 0D is divided into two. The first one is ionic and the second one is non-ionic. It will be discussed further in further slides. So 0D point defects are divided into vacancy, interstitial defect, Frenkel defect, or Schottky defect. 1D is divided into edge dislocation and screw dislocation. 2D is divided into grand boundary, twin boundary, or stacking fault. 3D volume defects are divided into dispersant, precipitate, and inclusion, void, or cracks. Now, point defects. Point defects are the irregularities or deviation from ideal arrangement around a point or an atom in a crystalline substance. Point defect occur in ionic and non-ionic crystal. Actually, if you see in the figure, if you see in the above figure, the one whole line is missed, so it is actually a line defect, or you may say it is a point defect. So when there is ionic and non-ionic misses, then it is called a line defect. If we see in the figure, we can observe it easily. Now, point defect types. 0 point defects are divided into two. The first one is the non-ionic crystal, and the second one is the ionic crystals. Non-ionic crystal are further divided into two. The first one we can see defect, and second one is the interstitial defect. Then ionic crystal are divided into Frenkel defect or Schottky defect. Now the first one is the non-ionic defects. Non-ionic defects are of two types. The first one is the vacancy defect, and the second one is the interstitial defect. Now vacancy defect. Atom missing from an atomic site occur due to imperfection packing due to crystallization. This result in decrease in density of the substance. Number of vacancy defect depend on the depend upon the temperature missing atom. Actually there are trillion of atom, it can be messed because so its density and mass will be decreased because trillion, there are trillion of atom can be messed from a crystal. It will not be one atom, it will be trillion atom. That's why its mass and density will be decreased or reduced. Now the second one is the interstitial defects, the addition of an extra atom within a crystal structure. This defect increases the density of the substance, causes atomic distortion. We can see an interstitial or inverse phenomena interstitial atom. Actually an interstitial defect, there is an addition of an extra atom. If we see in the figure in a red circle there is a blue atom, so a blue atom is added to a crystal, so its size will be increased. Actually there will be a trillion of atom can be added to in a crystal, so its size and density and mass will be increased. Now ionic defects. Ionic defects are divided into three types. The first one is the stoichiometric defect, the second one is the non-stoichiometric defect, and the third one is the impurity defects. Now, stoichiometric defects. An ionic crystal has a fixed ratio of anion and cation, which can be seen from its formula. This fixed ratio is called stoichiometry of that compound. If a defect is the crystal as such that the ratio between the cation and anion remains same as represented by its formula, the defect is called stoichiometric defect. Stoichiometric defect is actually it is the ratio between the cation and anion, and if and we will see the formula of the specific compound, like sugar has C6H12O6, it has their own ratio, like 6 ratio 12 ratio 6, and like acetic acid formula CH3COOH, so it has also a specific ratio of cation and anion. And then stoichiometric defect are further divided into two types. The first one is the Schottky defect, and the second one is the Frenkel defect. Now first one is the Schottky defect. It is a pair of anion and cation vacancies and added to maintain electrical neutrality. A number of missing cation and anion are equal, like anion and one cation is missing. If we see in the figure on the right hand side figure, in a red circle there is a pair of cation and anion are missed. Actually here electron and holes both are missed, so it will be a trillion of atom will be missed, so its density and mass will be reduced, like previously I discussed, and it is also decreased like ACL and KF, etc. And now the second one is the Frenkel defect. Cation being similar get displaced to interstitial voids. It is actually same like interstitial defect because and here its mass and density will not change, because here one atom will goes to the place of the other, like if you see in the figure on the right hand side, the one electron is goes from its place to the another place, so it is called interstitial defect, and there will be no change in the density or in the mass. There will be no changes, because here just whole or electron will move from its place to the another place, and combination of, you can see, interstitial form and no change in the density, like I said. So this was all about my presentation of defect and crystal, and thank you so much for listening. Thank you so much.